Hello, everybody. First, I'd like to ask you all how many of you are considering a career in scientific research, thinking about it, or are excited by it? Okay, so I see there's some hands out there. So I hope that you can take away and be inspired from some of my learnings from my journey in science. So, my journey in science started very early. I was very fortunate to go to a really good school, Bombay International School in Mumbai, and I had an excellent science teacher named Mrs. Kirti Behel. In the first standard, Mrs. Kirti taught us about gases and volume. In the second standard, Mrs. Kirti taught us about how water seeks its own level. In the third standard, Mrs. Kirti taught us about evolution. In the fourth standard, Mrs. Kirti taught us about space exploration and the Mars rover. So she was really a very great influence in capturing my innate childhood curiosity, which I think is something that we all have. So Mrs. Kirti was also extremely keen about us doing experiments. She was very instrumental in helping me understand that learning happens more by doing. So Mrs. Kirti made us do vermiculture. She made us get our hands dirty by working with earthworms, by studying how earthworms can compost vegetables and make the soil more fertile to grow better things. She converted our playgrounds into a lab. She would teach us how reactions happen with sodium and potassium, how they react with water and make an explosion. This was all really very fascinating for me. She was really very instrumental in making me believe that learning happens more by doing rather than by sitting in a classroom and by just reading papers or reading a book. So I sort of was very inspired by that. And I took all this with me and I decided to pursue a career, higher education in science. So, when I had completed my undergraduate degree in biochemistry in 2008, I thought I was at the top of the world. By this point, I had taken approximately 30 classes in chemistry, biology, physics, mathematics. So I thought, what more could there be to learn? I'm at the top of my knowledge, I know everything. But I was very pleasantly surprised and shocked when I reached the first year of my PhD studies. There, I realized that you could do an entire PhD in one atom, one molecule, one enzyme, or even just one reaction. And the deeper I went into that, the more I realized that in every subject, the more I read, the less I actually know. This was a really very humbling experience. And it became even more prominent when I started reading primary scientific literature. So, you ask me what is primary scientific literature? It's basically studies that scientists have done and they have published this in peer reviewed journals. So, the scientist has thought about a hypothesis. They have come up with an experimental design to test the hypothesis. They have come up with data. They have analyzed that data. They have interpreted it and they have come to a certain conclusion and now they have published it. So, this really made me realize that science is actually a very active process. It is about knowledge creation, not just about knowledge retention. While, of course, knowledge retention does have its place in science, and you experience a lot of it when you are an undergraduate student or even in high school, in the early years of your scientific career, it certainly has a place, and you do need to retain information to be able to reach a level where you can start thinking about it more creatively. So once I had reached that level, I was thrilled. I had retained all the building blocks, I had enough information, and I knew enough that I could start thinking about science and how it applies to my more daily living. Here, I'd like to narrate one incident when a friend told me this old wives' tale of why you should not drink too much water before you have your meal. So she said that was because it dilutes your stomach acids. Now, at this point, I was armed with the information that the stomach has a pH of roughly 1 to 3. There's about 100 milliliters of gastric juices, and that this is a buffered system. So I could do a kind of a quick calculation to know that I would need to drink a few liters of water to be able to have any significant impact on the pH of my stomach. Now, at that point, that seemed quite absurd that I would drink 2 or 3 liters of water before a meal. What was more realistic was that maybe I would drink a few hundred milliliters of water, and that would have absolutely no effect on the pH of my stomach. So, when I was able to convey this information to my friend, it made me feel really powerful. It made me feel empowered that nobody could take advantage of me or influence me without actually first giving me any kind of logical reasoning or any kind of evidence based reasoning. Now, in my PhD, I was also very fortunate to have a PhD guide or an advisor who was very hands off. So I had to depend on myself a lot to go out there in the library, find the resources that I needed, find the information, the papers, and also find the people whom I could talk to who would all help me fill the gaps in my knowledge that I needed to be able to graduate. So, this whole process was in very stark contrast to what I had experienced as an undergraduate and also in high school, where the information was provided to me and it was given to me on a platter. So, learning how to teach myself how to learn, that was a very new experience for me, and it was really very rewarding. This skill holds me in very good stead even today in my career, where things are changing so rapidly that you have to be able to teach yourself new skills very quickly, and you also have to be able to execute those skills very quickly. Now, the first 3 years of my PhD were not easy by any stretch of imagination. I went a very long time without really seeing much scientific success or having any exciting discoveries. This was especially difficult because at that point I was very used to being a academically very good student. I had had a lot of academic success until that point, and going through this period made me feel like maybe I'm failing, I'm not doing anything right. And I tried very hard to sort of force things in a way that would make my research go in a good direction. It kind of felt like using a hammer on an anvil to force something to happen. But once I was able to step back from that and eventually just see it as a situation where I thought, you know what, I'm giving my best to this. I'm doing everything that I can, but despite my best efforts, things are not going my way. And I learned to accept that something difficult is happening to me, something that I just need to embrace. And once I was able to expect that difficulties are just going to be part of my journey, this is just going to be part of my life, and sometimes things go wrong, I was able to approach the situation with a less personal aspect. So I was able to sort of feel less personally affected by this failure. And that helped me grow. It helped me also develop a sense of resilience. And after 3 years of being in that phase, in that state of mind, my advisor and I were able to sort of course a new path in my research. I was able to learn about an entirely new field that I knew nothing about of chemical neuroscience. And in a couple of years, I had some very exciting research. I had made some very interesting discoveries. And really, this helped me to think that instead of dwelling on my failure and spending more time in that mindset, it would have been better if I had just jumped back on the horse as quickly as possible and accepted, that that was part of my life and sort of moved on. So, developing resilience was actually much more important than dwelling on the failure. And this, I've realized, is kind of a muscle. When you exercise resilience over time, you can get better at it. And in the course of your journey, it'll become easier and easier if you keep exercising it and getting up back on that horse, which is more important than staying down and feeling like you've failed at something. Now, during those 3 years, I was also very hard on myself. I felt like maybe I'm being very unproductive, maybe I'm very lazy. But of course, That kind of thinking was not helpful at all. So I started thinking about that period more as a period of gestation. So in that time, it wasn't as if my growth was totally stalled. I was still growing as a person, I was just growing very slowly. And that time was the time that I was paying. It was a price that I was paying to be able to learn. So, in life, many times you might go through a period where you feel like you're growing very slowly. But surely those periods of time will be followed by a period of maybe more rapid productivity, just like I had found in my case that I was very quickly able to be successful after these 3 years of kind of gestating. I also learned in those initial years of my PhD that you might go a very long time without any kind of scientific success, without any discovery, or just like in life, as a student, you might go a long time without an achievement, without good grades, or in your job, you might go a long time without a raise, without an appraisal, without a promotion. And in those times, you have to be able to celebrate the small achievements. Those are the small things that might keep you happy, that keep you sane, and those are the things that will make you more appreciative about the things that you actually do have in a down phase of your life. And finally, I'd like to narrate an incident during which time I was teaching a course in astrophysics during my time as a lecturer in Frontiers of Science. In that time, I was teaching the students about an image that had been taken by the Hubble telescope. So, the Hubble telescope had captured this image of over 1,000 galaxies. And that image really humbled me. It really made me feel like we are living out of all these 1,000 galaxies in one small galaxy, in one small solar system, in one small planet, on one small country, in one small city, in one small house. And when you kind of take this zoomed out view on your life, you can really realize that your problems are much less significant than what they seem. And this thinking has really helped me get through many difficult and many painful situations in life when I'm able to see the bigger picture. Now, my PhD was also a time during which many myths that I had about what it means to be a scientist, what it means to be in science, were really busted and in very pleasant ways. So I thought that, I'm going to be a scientist. I'm going to have all this amazing information at my fingertips. I'm going to be able to solve problems. I'm going to know about everything about how the world works. And while that's true to some extent, science teaches us about how the reactions in our body happen, how molecules work, why the sky is blue, how the planets move. But science doesn't teach you about how relationships work, how families work, how administrations work, how does money work, how does finance work, how do you set up banking, how do big governments work. And these are all skills and knowledge that you are still going to need to have in your life to secure yourself. So, your learning as a scientist cannot end at just science. There's a whole other world out there which you still need to keep learning about, and that is a continuous process. There's also a perception that science is a very lonely pursuit. And while that's true to some extent, you might spend many hours, you might spend weeks, even months, ruminating about your data, thinking about how to set up the next experiment, thinking about how to interpret your data. Largely, science is actually a very collaborative process. Actually, my PhD was a very socially liberating time for me. It was a time during which I made some of my best friends. I had a wonderful advisor who loved to party, and my own PhD was a collaboration between three separate labs. So, unless you kind of, collaborate with many people, science has now reached a place where you cannot push the envelope of knowledge without collaboration. There's also a perception that science is not imaginative, it's boring. It is just about blah, 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 memorizing information. And while Of course, you do need to have some blocks of information. Science is actually a very creative process. If you think about what physicists do, they usually have thought experiments. And Einstein's theory of relativity and general relativity and special relativity, they both were giant leaps of imagination based on the knowledge and the equations and the framework that he already had to work with. So that is a very imaginative process. And finally, as we all know, in popular culture, scientists are always portrayed as nerds. So this was a huge myth that was busted for me. Most of my friends, they were very talented. They were not just in their books all the time. They were athletes, they were musicians. My advisor himself was a very popular musician. He was in a band and he had a large musical following. His fans knew him as a musician, but they thought that he did neuroscience on the side. So being a nerd and being cool are not really mutually exclusive to each other. And that's all that I have from my journey in science, and I wish you good luck in your journey. Thank you.